r is equals to xi comma xi plus 1. So divide the interval a comma b into non-overlapping subintervals xi comma xi plus 1, where 0 less than or is equals to I less than or is equals to n, with x naught is equals to a, xi plus 1 is equals to b. So starting element x naught, so that is equals to a, xi plus 1 is equals to b. Such interval, so that is interval xi comma xi plus 1 is an element in this case and were represented by a line. So that is line segment A is equals to x naught, x1, x2. So this is xi minus 1, xi plus 1. So B is equals to xn plus 1. So this is the interval on line segment. By Lagrange's interpolation formula, so by Lagrange's interpolation formula for, so this is Lagrange's interpolation formula for xi comma xi minus 1 comma xi plus 1. Lagrange's interpolation formula for xi comma xi minus 1 comma xi comma xi plus 1. So previous divide differences, unit 3. Using unit 3, Lagrange's interpolation formula for xi minus 1 comma xi plus 1. So that is capital N I plus 1 of x is equals to x minus xi by xi plus 1 minus xi. So this is equation number 2. So derivation important. Ni plus 1 of x is equals to x minus xi by xi plus 1 minus xi. The function ni of x are called shape function. So that is in diagram. So this is x, ni of x. So this is x-axis. So this is ni of x. So a, that is x naught, x1, x2 up to xi plus 1. So this is n values. So n naught to x1, n naught to x1, and xi plus 1 to xi plus 1 to xi, and ni plus 1 to xi. So this is the graph represented by this equation. It can be observed that the shape function ni is appearing only on the interval xi minus 1 comma xi minus 1 comma xi plus 1. So the shape function ni, so the function ni is appearing only in the interval xi minus 1 comma xi plus 1. In the two different ways, in all other intervals is assumed to be 0. So remaining intervals, the ni function is 0. Remaining all intervals, the ni function is 0 in the interval xi minus 1 comma xi. So therefore, the ni is defined as the shape function ni is defined as ni is equals to the previous one, x minus xi minus 1 by xi minus 1. Ni is equals to x minus xi minus 1 by xi minus 1. So the shape function is defined as follows. So this is the equation. In the interval xi comma xi plus 1. So this is belongs to only xi comma xi minus 1 interval only. So this interval. The shape function is different in different intervals. So in this intervals only, xi minus 1 comma xi interval, the shape function is ni is equals to x minus xi minus 1 by xi minus 1 belongs to xi minus 1 comma xi interval only. Next, in the second interval, in the interval xi comma xi plus 1, The shape function is xi plus 1 minus x by xi plus 1 minus xi. So we can take numerator denominator minus minus common. So x minus xi plus 1 by xi minus xi plus 1. So this is in the interval xi comma xi plus 1. So x-axis xi minus 1 xi plus 1. So this is ni. That is, so we can conclude that above shape function equations and diagram ni plus 1 of x plus ni of x is equals to 1. So ni plus 1 of x plus ni of x is equals to 1. So this is very, very important one. n ni of xj is equals to 1 if I is equals to j. So both cases ni of xj is equals to 1 if I is equals to j case. So remaining case, all other cases, I not is equals to j case is 0. So this is equation number 4. So equation 4, this is very, very important for further. Ni of xj is equals to 1 if I is equals to j. Otherwise 0, I not is equals to j case. Shape function of I at a point xj. 1 if I is equals to j. Remaining all other cases 0. Local coordinates. The coordinate system xi defined over the element e, for which x corresponding to xi is equals to 0 and xi plus 1 corresponding to xi is equals to 1 is called local coordinate system. So this is the definition of local coordinate system. So once again definition, the local coordinate system xi is defined as the element e for which x corresponding to xi is equals to 0 and x plus 1 is corresponding to xi is equals to 1 is called local coordinate system. Let the corresponding transformation be in mathematically the x minus a comma b into xi, x minus a comma b into xi. So the local coordinates x is equals to xi, that implies xi is equals to 0. So therefore a is equals to x1. So in finally, so we can write this is x minus xi plus b into xi, x minus xi plus b into xi. So that is x is equals to xi plus 1. So that implies xi is equals to 1 is given in definition. By using definition, these two. So these are using definition. If x is equals to xi, xi is equals to 0. If x is equals to xi plus 1, if x is equals to xi plus 1, xi is equals to 1 by using local coordinates definition. And length of the interval xi minus 1 comma xi plus 1 minus xi is equals to b. So therefore, from equation 5, so this is the equation 5. So this is equation 5, x minus a comma beta b into xi. From equation 5, ni plus 1 is ni plus 1 of x is equals to xi. So that is equals to x divided x minus xi by xi plus 1 minus xi. X minus xi by, so a printing mistake is there, x minus xi by xi plus 1 minus xi and 1 minus xi. So 1 minus xi is equals to x minus x I minus 1 minus x by x I plus 1 minus xi. So that is equals to ni of x. So these are ni plus 1. So this is ni. The transformation equation 5 becomes x minus xi minus xi minus xi into xi plus 1 minus 1 minus xi into xi plus xi into xi plus 1. The transformation of equation 5 in graphically in line xi is equals 0, here xi is equals to 1, here xi plus 1. The middle term is xi. So that Transformation 8 maps an element E along the x-axis into a standard interval 0, 8. In the standard interval 0, 8 on z-axis. So this is z-axis. So z is equals to psi function xi, xi plus 1, 2. Interval is defined as xi function is defined as xi, xi plus 1, 2, 0, 1. We denote 1 minus xi and psi by I small I and I plus 1 respectively. Note that I of x and I plus 1 of x, which are called local coordinates, are not independent. So these are the dependent variables. I plus 1. So therefore, I of x plus Li plus 1 of x is equals to 1. So these are the based on the previous example. This one based on this. Similarly, Li plus 1 of x plus Li of x is equals to 1. Same formula, but in place of shape function here we are defining L. So this one Li of x plus Li plus 1 of x is equals to 1. Also you have Li minus xi plus 1 minus x by xi plus 1 minus xi is equals to ni. So Li is equals to ni, Li plus 1 is equals to ni plus 1. So these three are equal. Li plus 1 is equals to ni plus 1, Li is equals to ni. So these are equation 10 and 11. In case of linear approximations, the shape functions are also local coordinates by equation 10, and hence the local coordinates of elements can be obtained by using the linear approximation, the solution function. So that is, so using Li plus Li plus 1 is equals to 1 formula. Li of xi plus Li plus 1 of xi is equals to x into xi plus 1 minus xi divided by xi minus 1 by xi. So this is by using Lagrange's interpolation formula. So multiply x is equals to Li xi plus Li plus 1 into xi plus 1. So we know that Li plus 1 is equals to 1 and xi into Li plus xi plus 1 into Li plus 1 is equals to x. So this one. So these two equations in matrix form. So Li plus 1 is equals to 1 and x into Li plus xi plus 1 into Li plus 1 is equals to x in matrix form. RHS 1 comma x or x comma 1. First x, next 1, x comma 1 and xi plus 1, xi first row, xi plus 1 and 1 comma 1 coefficients of Li plus 1 into Li plus 1. So this is the matrix form. Or so this can be written as Li into Li plus 1 is equals to xi plus 1, 1 inverse. This matrix inverse into x1. So we have to find out the inverse of matrix xi, xi plus 1, 1, 1. The determinant. So 2 by 2 matrix determinant is nothing but 2 by 2 matrix inverse. Adjoint of A by determinant of A. So this is determinant xi minus 1, xi plus 1 minus xi. So adjoint of A. So this is minus 1, xi plus 1, 1 minus xi into x1. So this is A inverse. 2 by 2 matrix inverse at any point on the element E can be expressed by the coordinates Li, Li plus 1. However, these coordinates are not independent since Li plus 1 is equals to 1. We have so differentiate on both sides dli by dx. So dli by dx is equals to minus 1 by xi plus 1 minus xi. So dl plus 1 by differentiation. So differentiation with respect to, so this is, so differentiation with respect to x. Li differentiation with respect to x. Li plus 1 differentiation with respect to x. So differentiate with respect to x, Li, here consider Li plus 1 is constant. So Li is constant, remaining case. So we are getting dli by d dou x is equals to minus 1 by xi plus 1 minus xi. So next, second one. So dli plus 1 by dou x is equals to 1 by xi plus 1 minus xi. So these are the 15, equation 59, 16. Equation 59, 16 implies that dli plus 1 is equals to 0. So that is differentiation of li is equals to minus differentiation of li plus 1. So this is equation number 17. Now consider I is equals to xi to xi plus 1 li dash li plus 1 dash into dx, where r comma s are positive integers from equation number 12. I is equals to xi to xi plus 1 ls of ls dash comma l r plus 1 dash into dx. So we are taking this integration. So dx is equals to dli into xi plus dli plus 1 into xi plus 1. So that is equals to minus dli plus 1 xi plus dli plus 1 into xi plus 1 using equation number, this equation. So replacing dli is equals to minus dli plus 1 here. So dli plus 1 is common. Dx is equals to xi plus 1 minus xi is equals to d into li plus 1. So now using this result to in the integration. I is equals to integration 0 to 1 li plus 1 dash into 1 minus li plus 1 power r. So this is power s power r. Xi plus 1 into xi plus 1 minus xi into d li plus 1. So that is in the integration. In the integration, so substitute dx value. So that is, so this value xi plus 1 minus xi into d li plus 1. In this case, so we can change the limits also. So 0 to 1. So I is equals to 0 to 1 li plus 1 power s 1 minus li plus 1 power r into xi plus 1 minus xi into d li plus 1. So that is equals to. So directly after integration, so formula is there. Integration formula. This is equation 18. X I plus 1 minus xi into r factorial s factorial divided by r plus s plus 1 factorial. So this is the formula for integration. Improper integrals. Xi plus 1 minus xi by r plus s plus 1 factorial into r factorial s factorial, where r comma s are positive integers. So therefore the following figure shows that the variation of local coordinates within an element E. So here 0 comma 1. So 0, comma 1, so 0, Li plus 1. So next, 1 by 4, 1 by 2, 3 by 4 is nothing but adding 0.5 to 0. 0 plus 0.5 plus 0.5, that is 1 by 2 plus 0.5, 7, 0.75. Next, here also 1, decreasing 0.5 minus 0.5, so that is 0.75, minus 0.75, that is 0.5, minus 0.5, that is 0.25. So these are the local coordinates. So that is xi plus 1, xi plus 1, xi plus 1, xi plus 1. If L based on L values 0 to 1. Next, 1 by 4 to 3 by 4, 1 by 2, 1 by 2, 3 by 4 to 1 by 4. So this is the graph. So this is the one-dimensional line segment, local coordinates. So this is the one-dimensional line segment proof. In this chapter, there is no examples, total proofs. Next, quadratic polynomial. Next, 16.4, quadratic polynomial. Now suppose you want a quadratic polynomial approximation. To get this, so take midpoint. So midpoint into consideration. So that is, so for example, same. So previous xi comma xi plus 1. So midpoint. So midpoint is nothing but xi plus 1 divided by 2 in quadratic polynomial. So that is the diagram. So this is xi plus 1 is nothing but midpoint. So xi plus 1 divided by 2. So here also we can use Lagrange's interpolation formula in chapter number 3 or unit 3. So by using apply Lagrange's interpolation formula at nodal points xi comma xi plus 1 and xi plus 1 divided by 2. So apply Lagrange's interpolation formula for these three nodal points. So that is xi plus 1 plus xi plus 1 divided by 2 and xi plus 1. The quadratic polynomial into approximation, the solution u in the element e as. So the solution of quadratic polynomial, so that is u power e of x. So this is based on Lagrange's interpolation formula on unit 3. So once again, Lagrange's interpolation formula. The Lagrange's interpolation formula is nothing but, so for example, x naught, x1, x2. So we can see unit 3, Lagrange's interpolation formula, finite differences. So Lagrange's interpolation formula corresponding y0, y1, y2. How to write this formula? By using Lagrange's interpolation formula. So that is x0, x1, x2, y0, y1, y2. So Lagrange's interpolation formula. First, we cannot consider starting term, that is x0. So x minus x1 into x minus x2 divided by. So first term would so substitute first term in numerator. So that is x0 minus x1 into x0 minus x2. So into corresponding y0. So we can take corresponding y0. So this is first term in Lagrange's interpolation formula. Is clear? Next term. In second term, we cannot consider x1. So that is x minus x0, into x minus x2 divided by. So substitute x1 in numerator. That is x1 minus x0 first term, x1 minus x2 as second term into y1 plus, next we cannot consider x2. We cannot consider x2. So that is x minus x naught into x minus x1 divided. So substitute numerator. Substitute numerator x x2 x2 minus x naught into x2 minus x1. So this is the Lagrange's interpolation formula. So using this Lagrange's interpolation formula, we can apply these three variables. So these are xi plus 1, first variables, and xi plus 1 divided by 2. These three. So applying Lagrange's interpolation formula, so that is x minus. So we cannot consider first term. So that is x1, xi. So next remaining two variables, x minus. So this one, midpoint, x minus midpoint into x minus xi plus 1. And so in this numerator, so substitute x is equals to xi plus xi. Write down in denominator. Is clear? So x minus second term into x minus third term divided by. So which term is leaving, that is substituting numerator. Xi substituting numerator. Xi minus same. Xi minus 1. Here I is there. Xi. Printing mistake. Xi is there. Is clear? Into u naught or ui corresponding u term. So this is first one. Next, the second term. So we cannot consider second term. So we can consider first and last term. So that is x minus xi, first term, into x minus xi plus 1, second term. And in this numerator, so substitute which term is leading. So that is, so this term. So substituting numerator, write down in denominator. So that is xi plus 1 divided by 2 minus xi into xi plus 1 divided by 2 minus xi plus 1 into u I plus 1 by 2. So this is corresponding u value. Ui plus 1 by 2. So next, last term. Here we cannot consider third term. So that is x minus xi minus 1. X minus xi into second term. X minus xi plus 1 divided by 2. And so substitute denominator. So denominator in numerator, so substitute x is equals to xi plus 1. Write down in denominator. So that is in place of x, xi plus 1 minus xi. Next, xi plus 1 minus xi plus 1 divided by 2 into ui plus 1. So this is ui plus 1 by 2. Next here, ui plus 1. Is clear? So this is the formula 19 by using Lagrange's interpolation formula. Next, the above equation 19 can also derived from the following way. So another way is there. Li is equals to 1. Li plus 1 is equals to 0. Corresponding xi. xi plus 1 by 2. Xi plus 1 by 2 corresponding Li is equals to 1 by 2. Li plus 1 is equals to 1 by 2. So next, so this is Li is equals to 0. Li plus 1 is equals to 1. Previous form. So this is based on local coordinates. So this formula. 1 minute. So these are based on previous
Sir.
formula. So that
Sir.
is
సార్
చెప్పండి అమ్మా.
ఈ టాపిక్ నుంచి ఒక క్వశ్చన్ కూడా లేదు కదా సార్ మోడల్ పేపర్ లో?
లేదు కానీ మేము టాపిక్స్ మాకు ఇచ్చిన ఆర్డర్ లో ప్రకారం మేము చెప్పుకుంటూ వెళ్ళాలమ్మా.
అవునా, సరే.
మాకు ఇచ్చిన టాపిక్స్ ఏమేమి టాపిక్ చెప్పాలో మాకు ఆల్రెడీ చార్ట్ ఉంటుంది. ఆ చార్ట్ లో ఏమన్నా ఆ టాపిక్స్ మాత్రమే చెప్పాలి మేము. నెక్స్ట్ క్లాస్ లో వేరే టాపిక్ చూద్దామమ్మా. ఇది టోటల్ థీరమ్స్ ఉంటాయి ఇందులో. ఇందులోంచి ఒక క్వశ్చన్ వచ్చింది, ఏదంటే ఇక్కడ లాస్ట్ లో ఉంటుంది 3 డైమెన్షనల్ క్వశ్చన్, 2 డైమెన్షనల్ లెగ్రాంజ్ పాలినామియల్ క్వశ్చన్ ఉంటుంది. చాలాసార్లు వచ్చింది అది. ఈ క్వశ్చన్ చాలాసార్లు వచ్చింది. క్వాడ్రాటిక్ లెగ్రాంజ్ పాలినామియల్ ట్రయాంగులర్ మెథడ్. ఈ క్వశ్చన్ వచ్చింది 16.7. ఈ క్వశ్చన్ చాలా సార్లు వచ్చింది. ఇది కావాలంటే ఒకసారి మీరు ప్రీవియస్ పేపర్ చెక్ చేసుకోండి. ఈ క్వశ్చన్ వస్తుంది 16.7 క్వశ్చన్ ఉంటుంది మీకు. క్వాడ్రాటిక్ లెగ్రాంజ్ పాలినామియల్ ట్రయాంగులర్ ఎలిమెంట్. ఆ క్వశ్చన్ చెప్పిన తర్వాత చెప్తానమ్మా. ఇది Li is equals to xi plus 1 minus xi by xi plus 1 minus xi. Li plus 1 is equals to x minus xi by xi plus 1 minus xi. So that is u power e of x is equals to ni plus 1 ni plus 1 by 2 into ui comma ui plus 1 by 2 ui plus 1. So this is equation number 10. Equation 20. So where ni plus 1 by 2 ni plus 1 are the functions of li comma li plus 1. From equation number 4 n of 1 comma 0 is equals to 1. N of 1 by 2 comma 1 by 2 is equals 0. Ni of 0 comma 1 is equals 0. So this is based on equation 4. So that is in line segment equation 4 in line segment. So this equation. So this is ni of xj is equals to 1. Ni of xj is equals to 1 if I is equals to j case. Remaining all cases I not is equals to j case 0. So using this formula, so I is equals to j case 0. Remaining all are, so this is 0, printing mistake. Here 0, here 1. So ni of 0, 1 is equals to 0. I naught is equals j case 0. Remaining all cases 1. So ni is equals to c into li minus 1 by 2 li. So c is a constant to be so 3 points. So 3 points. First point n of 1 comma 0, ni of 1 comma 0. So c is equals to 2. Next ni of 1 by 2 comma 1 by 2 case. So that is ni is equals to li minus li plus 1 into li. So similarly, so using so this ni plus 1 1 by 2 of 1 comma 0 is equals to 0. I naught is equals to j case 1 naught is equals to 0. So here I is equals to j ni plus 1 by 2 of 1 by 2 comma 1 by 2. So that is equals to 1. So next here I naught is equals to j. Here also 0. If these two coordinates are equal, then we are getting 1. Otherwise 0. Here also 1. Here 0. So 1 ni plus 1 of 1 comma 0 0. Ni plus 1 of 1 by 2 comma 1 by 2 1. Ni plus 1 of 0 comma 1 is 0. So these are the, so we are getting ni comma ni plus 1 by 2 and ni plus 1. So these are the formulas. Ni plus 1 by 2 is equals to 4 into li plus 1 by 2, li plus 1. So next, ni plus 1 is equals to li plus 1 minus li into li plus 1. So these are the formulas for quadratic polynomial. So next, cubic polynomial also same here. So based on this equation, these values we can write cubic polynomial also. So 1 by 0, 1 by 2. So next, 2 by 3. Next one. So that is we can add 1 by 3 plus 1 by 3 plus 1 by 3. Here decreasing. So 1 decreasing minus 1 by 3. So that is 2 by 3. Again decreasing 1 by 3. So that is 1 by 3. And decreasing 1 by 3, 0. So these are xi plus 4 by 3. Xi 2 by 3. Xi plus 1. Is clear? So this is the cubic polynomial. Here also we can use Lagrange's interpolation formula. Here also same. Ni of 2 by 3 comma 1 by 3 is equal 0. Ni of 1 by 3 comma 2 by 3 0. Because these coordinates are not is equals to, in this case we are getting 0. Ni of xi is equals to 1 if I is equals to j. So that is 2 by 3 not is equals to 1 by 3. So here 0. Here also 0. Here also 0. The final formula. So these are the final formulas for cubic polynomial. N t plus 1 by 3 of li comma li plus 1 is equals to minus 9 by 2. Minus 9 by 2 li into li plus 1. 1 minus 3 li. So this is first one. Second one. N t plus 2 by 3 of li comma li plus 1 is equals to 9 by 2 li plus 1. 2 minus 3 li. So these are the three formulas. Ni plus 1 of li comma li plus 1 is equals to 1 by 2 li minus 2 li plus 1 into 2 li minus li plus 1 into li plus 1. So these are the formulas in cubic polynomial. So these are the formulas in quadratic polynomial. So these two formulas. And line segment formulas. So this is the line segment formula. So line segment, quadratic polynomial. So these two are formulas for quadratic polynomial. Next, cubic polynomial. So these two are three formulas for cubic polynomial. Is nothing but we can divide the interval into three subintervals. Next, cubic Hermite polynomial. Here also same. So these are the one-dimensional case. Cubic Hermite's polynomial. So it is denoted by capital H. So cubic Hermite's polynomial is denoted by capital H. So these are the formulas for cubic Hermite's polynomial. So this proof is no need. So two-dimensional element. So two-dimensional element. So in this two-dimensional, so this is a very, very important quadratic Lagrangian polynomial, triangular method. The triangular method. So this is the triangle. First point x1, y1, second point x2, y2, third point x3, y3. So this is common equation for all nodes. So we can write each and every node. In first node u1. u1 is equals to a plus bx1 plus cy1. So next second node u2. a plus bx2 plus cy2. So similarly third node u3 is equals to a plus bx3 plus cy3. So these three equations at three nodes. So this is the common equation. A plus bx plus cy is the common equation. So we can apply for each and every node. First node, second node, third node. So u1 is equals to a plus bx1 plus cy1. u2 is equals to a plus bx2 plus cy2. u3 is equals to a plus bx3 cy3. So these are the three equations. Next, these three equations in matrix form. So this is column matrix. Column matrix. So next, 1, x1, y1. First, 1, x2, y2. 1, x3, y3. A, B, C. So these are the column matrix. So that is U is equals to A into A bar. U is equals to A into A bar. So this is the matrix form. So we can write, we can find out A bar. So A bar is equals to A inverse into U bar. A bar is equals to A inverse into U bar. So A bar is equals to, so 1 by det A into adjoint of A. So this is A matrix. So this is A matrix. So we can find inverse of A matrix A, adjoint of A by determinant of A. So this is 1 by 2 det A. Det A, and this is adjoint of A into U matrix, U1, U2, U3. So that is where 1 by, so this is determinant is equals to 1 by 2 determinant of 1 x1 y1 1 x2 y2 1 x3 y3. So the area delta E is equals to the one of the magnitude of the area triangle area is equals to the half of the magnitude of det A. So that is the nodes, the det A is the negative of the nodes 1, 2, 3. Nodes 1, 2, 3. So this is anti-clockwise direction. So that is, so directly we can say that u power E of x comma y is equals to 1 x y row matrix into A inverse u1, u2, u3. So that is A inverse is equals to, this is A inverse matrix is not given values. So we are assumption x1, x2, x3 nodes. So 1 x y divided by 2 into delta E. So determinant of matrix. So this one, determinant of this matrix. So this is adjoint of A, u1, u2, u3. So our assumption, so this is must to be n1, n2, node 1, node 2, node 3, like this. Row matrix node 1, node 2, node 3 into u1, u2, u3. So here node 1, node 2, node 3 is given as. So node 1 is equals to, so this formula, node 1, n1 of x comma y. So this is important formulas for next proof. Node 2, node 3. So node 1 is equals to x3 y3 minus x3 y2 plus x into y2 minus y3 plus y into x3 minus x2 by 2 into del E. So area of determinant of triangle n2 of x comma y. So x3 y1 minus y1 x3 plus x into y3 minus y1 plus y into x1 minus x3 divided by 2 del E. Next, n3. So these are the formulas for node 1, node 2, node 3. Node 1, node 2, node 3. The first degree polynomial. So this is equation number 38. The functions n1, n2, n3 are called shape functions. So shape functions ekkodochayi. So these are in line segments starting n1, n2, n3 are the shape functions. The sum of all shape functions is equals to 1. So that is n1 plus n2 plus n3 is equals to 1. And also is given n1 of xi comma yj is equals to 0 if I is equals to j. If is equals to 1 if I is equals to j. So these are the shape functions. The functions n1, n2, nodes n1, n2, n3 are called shape functions, and sum of all shape functions is equals to n1 plus n2 plus n3 is equals to 1. And n of xi comma yj is equals to 0 if I naught is equals to j. That is equals to 1 if I is equals to j. Is clear? Next. Next, a diagram. Node 1, node 2, node 3. So this is P is nothing but midpoint. P of x comma y. So consider any point P of x comma y belongs to the element show like midpoint. So P can be associated with the area of the local coordinates. So that is local coordinates are L1, L2, L3. So the local coordinates are defined as L1. So the L1 is defined as area of P2 comma 3. So that is area of this triangle. Area P2 comma 3. Area of the triangle divided by area of total triangle. Area of 1, 2, 3 is nothing but area of the total triangle. Next, L2. L2 is nothing but removing 2 is nothing but so this value. So removing 2 is nothing but so this is. So area of this one. L2 is nothing but area of 3, 1. So 3, 1 divided by area of total triangle. So next L3. L3 is equals to area of this triangle. Area of this triangle divided by total area of total triangle. So these are the L1, L2, L3 coordinates associated with point P. So these L1, L2, L3 are called local coordinates. So these L1, L2, L3 are called local coordinates. Is clear? Local coordinates and N1, N2, N3 are called shape functions. The sum of shape functions N1, N2, N3 is always 1, and the local coordinates are L1, L2, L3 is defined as area of 2, 3, area of total triangle L1. And also is given L1, L2, L3 are called coordinates are national or local coordinates. So therefore, the following assumptions. So the sum of all local coordinates also 1. L1 plus L2 plus L3 is equals to 1. All Li is greater than or is equals to 0. I is equals to 1, 2, 3. All are positives. Is nothing but all local coordinates are positives. Second point, Li is equals to Ni. First local coordinate is equals to first shape function. Second one also same. Third one also same. And third point, N1, N2, N3 is equals to, so that is L1, L2, L3. Already we know that N1, N2, N3 formula. Here, N1, N2, N3 formula. So this is N1, N2, N3 formula. So this is N1, N2, N3 formula. Same formula for local coordinates also. L1, L2, L3. So that is the local coordinates L1, L2, L3. 1 by 2 into delta E. So this is adjoint of A inverse into 1 x y. So that is finally 1 xy is equals to 1 1 1 x1 x2 x3 y1 y2 y3 L1 L2 L3. all the coordinates are used to define the P only. All the local coordinates L1, L2, L3 are used to define point P only. The sum of all independent local coordinates, that is L1 plus L2 plus L3 is equals to 1. We study the properties of L1, L2, L3 from 38. From equation 38, it can be seen that L of x comma y is linearly in x comma y. A diagram. So these are the diagram. So this is local coordinate L2. So this is L1. So this is L1, L3, L2. So this is P point. So line segment. L2's line segment. L3. L of x comma y is equals to 0 represent a straight line. Also, L of x2 comma y2 is equals to L of x3 comma y1 is equals to 0. So these are the points. L1 is equals to L2 is equals to L3 is equals to 1 by 3. This triangle can be divided into 3 parts. So that is L1, L2, L3 all are equal. So that is 1 by 3, 1 by 3, 1 by 3. So final equations. So these are final. X is equals to x1 L1 plus x2 L2 plus x3 L3. And y is equals to y1 L1 plus y2 L2 plus y3 L3. So this is the final formula. Integration, double integration of L1 dash L2 dash L3 dash into dx dy is equals to r factorial s factorial t factorial into 2 into determinant of a divided by r plus s plus t plus 2 factorial. So this is the final answer. So next class, we will discuss quadratic Lagrangian polynomial. So this is a very, very important question in this topic. So we will discuss in next class.